carrying a load of 800 kilonewton per meter ton. Okay, the allowable soil pressure is given as 200 kilonewton per meter square. So here allowable soil pressure is given. Okay, footing, the wall is given. That means this footing is running along the wall. Okay, so for 1 meter width wall is given, and this footing is carries a load of 800 kilonewton per meter. If you have this kind of problem, if you just check our previous this one, just I'm showing you. So this is strip footing, right? So here if you see, what we can do is we can calculate load, we know, allowable soil pressure we know, we can find out the width we can find out here likewise. Okay, by using the plain concrete width, and actual width is provided, and actual soil pressure also can find out dividing the this area whatever we are providing exactly. Suppose 4 meter, so 4 meter, if we divide it, it will give the actual soil pressure. Then what is our next formula? Here we are finding the bending moment and shear and so on. Once you know this bending moment and shear force, calculating the reinforcement is very easy. Okay, we can use our RCC, and we can find out. Okay, once you calculate this one, then what we have to do is, if you recall this one, maximum bending moment and maximum diagonal shear at a distance of d. Okay, punching shear. So here what you can do is, bending moment you can calculate by using this one formulas. B we know, this small b also we know, we can get the maximum bending moment. Okay, and we can find out the diagonal shear also. There are formulas given for diagonal shear also. Same thing, you can use it and you can find out this diagonal shear. Okay, once you know, because after that in the soil mechanics books they have not given how to find out the reinforcement and other things. That what you have to do is you have to refer to our RCC books. Okay, so by using that one, and we can say that footing is designed, and we know that 4 meter and this width and the cover would be there. So longitudinal reinforcement and the vertical, I mean both the side reinforcement can be provided 20 mm bars and 10 mm. These things you will get it from our RCC. Okay, so this is how generally we do it by using our soil mechanics. So next is design a square reinforcement footing for the following data. The data is given. Okay, column load is given here. That is, this is a spread footing. Spread means isolated footing. We have to go to, this is spread footing, isolated footing. So we will use these formulas. Okay, area will find out, and actual soil pressure will find out, and maximum bending moment, shear force, and this D naught. D naught is the, for the punching shear, the critical section is taken as a distance of d by 2. That already we have seen from the face of the column. The general overall depth of the footing is determined. So overall depth of the footing d naught also can be determined. So this is our spread footing. Okay, already we have seen it, and b and the d is the depth, and effective depth, and here at a depth of at a distance of d, maximum diagonal shear will happen. Here there would be maximum bending moment at the face of this column. So column load if it is given, column width is if it is given, and we can design a foundation also. So what it is here, if you see here again, likewise whatever you have seen here for spread footing, what we do is area will calculate. So once you load, we know that column load is 800 kilonewton, and the allowable soil pressure also given. We can calculate allowable soil pressure also by using our theory and other equations. Okay, size of the column also given, the pillars whatever you see. Okay, 0.4 mm, 0.4 meters, not mm, meters. Okay, and this is our footing, isolated footing. What we first step is to calculate the area. Once you know area, since it is a square footing, square root will give the width. Once you get the width, actual pressure can be calculated. Okay, so 800, this one, this is the actual pressure. Then overall depth, it is given by using formulas whatever we have here. Okay, then we can calculate bending moment and shear force also. So by using this one, d naught can be calculated here. Taking the SP, this is SP is nothing, is safe punching shear. So we are assuming something that suppose safe punching shear is 1000. Just assume, okay, and cover in the sense this is the cover between these two here, the reinforcement and that, because we cannot provide reinforce on the surface, right? We'll provide some cover. So once you provide some cover, then only rusting, we can prevent the rusting of the iron and other things. So whether it may be uh, beams or columns or whatever may be slabs, we'll be having IS code is given some cover also. So but we have to follow that one, and we have to provide the reinforcement here. Okay, that's what it is given. So what we can do, overall depth can be calculated. So cover just we have assumed it, okay, 0.06 suppose, and we can find out the D. Solving this one, D will get it. And once you get D, it is just rounding up 0.23 instead of 0.23 adapted. They have adapted 0.75, and this when you cover this cover, then you will get the D naught. That means the overall depth. So 0.33 5 meter, okay, 0.335, then it's not in a half meter also, that's a width. Then what we'll do is we'll calculate this WL square by 8 kind of things, okay. Bending moment, once you calculate all parameters are there here, okay, 200 is there, width is there, D width is small, B is the column width, okay, everything is there. We can calculate the bending moment. Again what we'll do is we can calculate the diagonal shear. Again the same formulas, we know all the parameters. Then maximum force for bond is given. So if we have this data with us, then what we have to do is then again go to RCC, then calculate the reinforcement and other details. So likewise, all there are some problems given: spread footing, strip footing. Now, if you look at this, is the combined footing. Okay. So how we have designed the combined footing? We have assumed that two loads are acting on this beam. Okay. So same thing they have done it here. Design a rectangular combined footing for two columns here. Taking the soil pressure also is given. So if you recall our this one combined footing, just again show you, we calculate X bar and other things, right? Q is the total load, and here this has X2 and this X bar we have calculated, A we have calculated. So follow these steps, okay, step by step. You can do all these things. So one reading is enough. There is nothing like, okay, after calculating X bar, we have calculated L and the B here, then actual pressure and so on. And finally, what we do, we will design like a determine the longitudinal reinforcement maximum moment, and the here how we have designed. So this will be designed like this, okay. So these are the q1, q2 is given. So here what we are doing, X bar we are calculating it, and finally the soil pressure is given. If you look at here, you follow one by one step here, okay. So q is nothing but the q1 plus q2, and X bar, if you see this X bar we have calculating here, okay, X bar and all we are calculating here. Then after that A we are calculating area. Then after that we are calculating this L by using this one. So it's very simple, okay, nothing to worry much. L area will get, L we get, then we'll get the B. So B we can calculate area by L, we'll get the B. So B is given at 2 point. Here we have written 2 point width, okay, not length, width. Length I have already given. So likewise, after calculating that one, then actual soil pressure can be calculated. Okay. Then actual soil pressure per meter run can be calculated. Then what we'll do is figure shows the shear force diagram. Shear force is 0 at the distance of. So what we'll do is shear force and bending moment diagram can be cal drawn for this one. So they have already drawn it, shear force and diagrams. Okay, we can reverse it and also can be done. And when you calculate shear force and bending moment diagram, where the maximum bending moment is there, shear force becomes 0. So likewise, based on that, what we'll do is finally The maximum moment he also calculated the footing can be designed for the above values of maximum bending moment and the shear force. Our main aim is to calculate the maximum bending moment and shear force. So based on that, we can further use. So likewise, now here it is a trapezoidum, it is given. So likewise, if you see, so same thing, same formulas, whatever is given here, trapezoidal footing, also same thing, Q1, Q, you can calculate X bar, you can calculate and so on, whatever is given, combine. So these formulas been used here and we can calculate the maximum. At the end, if we come here, so the footing can be designed for maximum bending moment and checked for the shear force. So likewise, this is strip footing. The similar way, strip footing also given, and so on. What else? This rough foundation also, if you recall, EX, EY, we will calculate it. Okay, and again, shear force bending moment can be drawn, and the finally, if you see here, so maximum bending moment is given, maximum shear force is given here. So this thing also given here, staff footing also given, this footing also again already we have seen. Design of raft foundation also we have seen in the 22 class here. So yesterday we have seen this mat foundation also. So these steps we have to follow. Okay, that's what they have done it. So steps you can follow and you can design. So this is all about how we will design it. What I have done is you try to work out some problems there, then you will understand, because just listening may not help you unless you do it something. So here what you will do is I have forwarded you the assignment. Same Aurora book assignment, five more questions I have forwarded to you. You try to solve. Those questions are very easy. Answers are given. You try your own. Then what will happen? No? Then you can submit. The submission date is 15th November. So 15 days I am giving. Just five questions I am giving you. Okay, just five questions, and everything is you can solve by using this what do you say, our Aurora book only.